I'm Alex. This is Code Along with Alex, and let's get right into closures. So we check the docs, the Rust by example. We can see there's some text. I'm just going to read this real quick, and then we'll get right into the code. But closures are functions that can capture the enclosing environment. For example, a closure that captures the x variable, as seen here on the docs page. So the syntax and capabilities of closures make them very convenient for on-the-fly usage. Calling a closure is exactly like calling a function. However, both input and return types can be inferred, and input variable names must be specified. Other characteristics of closures include using a double pipe instead of parentheses around input variables, optional body delimitation, using the curly brackets for a single expression, mandatory otherwise, and the ability to capture the outer environment variables. So let's get to coding. I'm going to make a new cargo project called closures, and let's change into closures. I'm going to open the main.rs, and then we can just get into coding. So we're just going to increment using closures and functions. So inside our function, main function body, let's nest another function, and I could just call it function. And it takes an input parameter I of type integer 32. It returns type integer 32. We got some funky closure goodness going on. So I plus 1. Actually, no, this is just the body. It just looks weird because we're not like returning it like that. It's just, you can do it on a single line. It just looks kind of funky if you're not used to it. Okay. So next, closures are anonymous. And so here we're going to bind them to references. And annotation is identical to function annotation, but is optional, as are the curly brackets wrapping the body. And so these nameless functions are assigned to appropriately named variables. So this, what we're going to get into right now, really reminds me of like Python Lambda functions. So these anonymous functions. So it's interesting. Cool. Closure annotated, and then get our pipe going. I of type integer 32, and then that returns integer 32 type of I plus 1. Okay, so you can see how we're starting to morph our function logic into closures. So let's do another closure. This one's going to be inferred. Closure inferred equals, gotta get that pipe, I, and then just blank. Okay. And then let I equals 1. Okay, so now we're going to call the functions and the closures. So our old friend, the println macro function, and then we're just going to pass, oops. We're not going to pass oops, we're going to pass the function results into this string in between these curly brackets. And so we'll do that by just passing function I after the comma. Cool. And then I'm going to copy this statement a few times and then just tweak the string and then what's passed just to save myself time. So closure, actually, copy paste for the win. And then, oops. Lots of oops today. Haven't had too much coffee yet, so that could be why. Still waking up. It's morning for me, whatever time it is for you. Thanks for joining. Really appreciate your company on this learning journey Also, we'll spell inferred with 2 R's. No biggie if you choose not to. Okay. But yeah, I really appreciate your company and learning with me. So if you have anything to say, don't hesitate to leave a comment. I'll get back to you. Yeah, just appreciate all the views and subscribers. Thanks. Still a small channel, but it's cool to see the growth happening. So just want to shout out all the community. So thank you. Okay, so here we have a closure taking no arguments, and it returns an integer 32, and the return type is inferred. So let 1, and then we got that pipe, then 1. It's funky. It's different than functions, but I could see how sometimes you don't need a full function to get the program or the computer to do what you need, and so something like a closure could be sufficient in many use cases. Not all, but many. So closure returning 1, curly brackets, 1. Okay. Semicolon, it's just how it is. Save it. Let's do cargo run. Oh, we got 1 error. That's fine. That's fine. Oh yeah, because I totally forgot to add stuff here. Okay. So for the closure inferred, I totally skipped my line of sight. It was just like, oh, that's not actually relevant, but it is. So we're not going to actually pass the, what's it called? The type annotation, but otherwise it's essentially the same kind of statement as closure annotated, but you can see we're able to remove curly brackets and we're just not passing the types. And we have to add the semicolon, otherwise it'll yell at us as it did here. So let me clear this terminal output just to clean up our workspace. I like it a little neater than that. It's just personal preference. You can keep it the other way. Got another error. Okay, that's cool. It's fun. We're learning. Maybe it's oh, that's why. I don't need to actually pass the arrow symbol because I'm not suggesting any specific type that is returned. So that was my bad. Let's clear that again. Ooh, okay, it worked. So we can see that the function returns a value of 2 because 1 plus 1 is 2. And then closure annotated also returns a 2, as this closure inferred. And then the closure returning 1 returns 1. Very cool. That was a whirlwind tour of closures at a high level, but we're going to drill down over the next few cargo projects today and get a better idea of closures. So if we toggle back to the docs, you can see there's this whole nested hierarchy of lessons for today, or maybe not lessons, but examples, REST examples. And so we just did the closures section. Now we're moving on to capturing. So let me read a little bit and then we'll get back into the code. So closures are inherently flexible and will do what the functionality requires to make the closure work without annotation. Sweet. Shameless plug for Boartooth Tattoo mug. It makes the coffee taste better. I don't know how the science works. It just does. Okay. So this allows capturing to flexibly adapt to the use case, sometimes moving and sometimes borrowing. So closures can capture variables by reference using the &t, by mutable reference like &mut t, or by value, just straight up t. So they preferentially capture variables by reference and only go lower when required. So let's get back into the VS Code. Return to the main subdirectory for today, and let's create a new cargo project. Cargo new, capturing. And then let's change into capturing. And then close up our closures folder. Oops. And then open up main.rs inside of captured. Okay, so now we can just get right into the code and do it. So inside our nest, inside of the main function body, let's pull out a use statement, and we're going to use the standard library mem utility. I'm going to look that up real fast. And so these are basic functions for dealing with memory, and they contain functions for querying the size and alignment of types, initializing and manipulating memory. And so I guess we're going to do some memory stuff in this lesson right now. Okay. Let me get back to VS Code. So let's bind a variable called color, and that'll be type string, and then from an input phrase green. Okay. And so a closure to print color, which immediately borrows ampersand color, stores the borrow and closure in the print variable. It will it will remain borrowed until print is used the last time. And so the println macro only requires arguments by immutable reference, so it doesn't impose anything more restrictive. So that was a lot of speaking. Let's get to typing. So let print equals, only a single equals, my bad. Got our pipes going, our closures, capture, and then let's do the println macro. And then we're just going to pass color. Then color. We want to print out our color inside this inside this closure. So now we can call the closure as such. So let's just run this code now and see what happens. Cargo run. It's cool. The unused import, no biggie. And then you can see color green. Nice. So now let's borrow color immutably again, because the closure only held an immutable reference to color. So we can do that like this. Let reborrow equals ampersand color. And then we can print again. Let's save this. Oops, we don't want to add an S. You just want to save the file. Cargo run. Good to go. Okay. And then let's do this yet another time. So a move or reborrow is allowed after the final use of print. So you can see, let color moved equals color. And then we can save and run this. No errors. Cool. And so now let's create another variable binding for ourselves to explore other aspects of capture closure goodness. So let me just add a break. So let's bind a mutable variable called count. We're not going to pass a type, but it's going to be integer. And so a closure to increment count could take either ampersand mute count or count, but the ampersand mute count is less restrictive, so it takes that. immediately borrows count. Cool. A mute is required on increment because an ampersand mute is stored inside. Thus, calling the closure mutates the closure, which requires a mute. Okay. That'll make more sense once I start typing. So let mute inc equals closure pipe stuff. And then count plus equals 1, incrementing the count by 1. And then using our println macro to print out the value of count. Nothing too fancy. A couple semicolons. And then let's call the closure using the mutable borrow. So let's save, run this. You can see count's working golden. So the closure still mutably borrows count because it is called later. So an attempt to reborrow will lead to an error. So it's a little different than before. Reborrow equals ampersand count. What happens here? Okay, so that worked. Interesting. Rebar. Okay, and then let's run increment again. Okay. So immutable borrow occurs here. So if we try to increment it, it's not chill. Because there, okay, that makes sense. So let's comment this out again. And then we should just be able to increment as expected. Yeah, and the count goes up by 1. Very cool. Okay, so the closure no longer needs to borrow at mute count. Therefore, it is possible to reborrow without an error. So we can do that like let count reborrowed equals mute count. No errors. Okay, and then let's do another kind of break in our function logic just to help us kind of keep track of what we're doing. This isn't any kind of code that will optimize or like impact the application. It's really just when we're maybe looking back, we can see, oh yeah, this is one section, and then there's a comment, and then there's another section of the lesson. That's all it really is. Okay, so let's bind another variable. Let movable equals, using our box new, the value of 3. So the mem drop, so we're going to use the std mem crate or library. And so that requires t, so this must take by value. A copy type would copy into the closure, leaving the original untouched. A non-copy must move, and so movable immediately moves into the closure. So let consume equals double pipe closure stuff, print ln macro, and then just some text, some movable, and then curly brackets to interpolate the string, but this time we're going to use the debug format with the colon question mark, and then movable, semicolon, and then let's do the mem drop. Nice. Another semicolon, and then a third semicolon for good measure. Very cool. And then let's save this and run it, see what happens. Okay, nothing was printed out. That's totally chill. So now let's actually call the closure. And so we do that as such, consume, save, let's run that. Nice, so movable is 3, but the consume consumes the variable, so it can only be called once. So if we try to run consume again, there's an error. So yeah, we can't recall consume. And then one last kind of logical break in our main function body before we move on to another section is using move before vertical pipes forces closure to take ownership of captured variables. Excuse me. Not used to so much talking. Okay, so let haystack equals, we're going to create a vector using the vec macro, and it's just going to have 3 values, 1, 2, 3. And so let contains equals move. I got to do the pipes, not the curly brackets. So move the needle. Haystack dot contains needle. So let's now do println macro, empty curly brackets to just print out what we want, and then it contains closure, capture. No, it's closure. Yeah, the contains closure, but passing ampersand 1 as a value or as an input, and then let's copy paste this line and then modify it to pass an ampersand 4. Let's save. So you can see it kind of is a Boolean result. So it's checking if 1 was contained in haystack. It was, so true is returned, and 4 was not, and so false was returned. Very cool. All right. Next, we're going to be moving on to as input parameters subsection of Rest by Example functions chapter. So this one has a lot of reading, but let's get into it. While Rust chooses how to capture variables on the fly, mostly without type annotation, this ambiguity is not allowed when writing functions. When taking a closure as an input parameter, the closure's complete type must be annotated using one of a few traits, and they're determined by what the closure does with captured value. In order of decreasing restriction, they are fn, the closure uses the captured value by reference, %t. fn mute, the closure uses the captured value by mutable reference, %mute t. And then fn once, the closure uses the captured value by value t. On a variable by variable basis, the compiler will capture variables in the least restrictive manner possible. For instance, consider a parameter annotated by or annotated as fn once. This specifies that the closure may capture by %t, %mute t, or t, but the compiler will ultimately choose based on how the captured variables are used in the closure. This is because if a move is possible, then any type of borrow should also be possible. Note that the reverse is not true. If the parameter is annotated as fn, then capturing variables by %mute t or t are not allowed. So in the following example, we're going to try swapping the usage of fn mute, and fn once to see what happens. So I'm gonna create another cargo project for us, changing back into the main subdirectory for today. It's cargo new. We call it as input parameters. Change into as input parameters, and then open main.rs, and then get to coding. So a function which takes a closure as an argument and calls it is what we're going to start with. The triangle brackets f denotes that f is a generic type parameter. So I'm going to delete this function main for now, because we can bring it back in a second. But we'll start with apply. And you can see the generic type parameter f. And it takes input of type f, where fn once and so then this just returns f. Okay. Next, let's create another function called apply to 3. Also takes a generic type parameter f. But it takes a closure and it returns an integer 32. Interesting. This is different. I haven't seen this kind of Rust programming yet. F3. Okay. I guess these should go all the way back. Okay, and now we can get right into our main function body and see what happens. So let's do fn main. Again, we're going to use std mem. So let's bind a string variable, or not a str, like uppercase string, but it's a string type, or a string hello. And so let's then bind a mutable variable called farewell, and that'll be goodbye. And then we're gonna create own data from our borrowed data using the toOwned method. Now we're gonna capture our two variables, greeting by reference and farewell by value, using a closure called diary. So let diary equals vertical pipes, curly brackets. So we'll start out with a println macro. I said, then empty curly brackets, and then we're going to pass greeting to start, semicolon. And then we'll do farewell dot push str, and then we want to add some exclamation points to emphasize the urgency of the farewell. Next, let's println macro again. Then I screamed into the void, give me jazz. No, farewell. Yeah, I scream into the void and all I hear is jazz. Now I can sleep. Zzz. Sleep like a bee. Okay, cool. And so next we're gonna manually call drop, and this will force farewell to be captured by value. And this will now require the fn once style. So mem and drop farewell. Okay, almost there. So now we're gonna, now the diary has been defined, we're gonna call, call the function which applies the closure. So we're gonna apply diary, and then let's bind a new variable, or a new closure, excuse me. So x, and then 2 times x, and then println 3 doubled, empty curly brackets to get the value. So apply to 3, and then this is where we'll pass double. Okay, save this. Let's do cargo run, see what happens. I said hello, and I screamed goodbye. Now I can sleep. 3 doubled is 6. Okay. So this was kind of the first run through. Now the docs encourage us to try changing some of the function types to not fn once. So let's see what happens when we adjust this to just be fn. Will it work? The perpetual age-old question. It did not work. Okay. And then what if we do fn mute? It did not work either. Okay. Nice. And then back to fn once, it works as expected. Interesting. So you can see how it really does impact your code success. These generic types and or the not generic types, the traits, excuse me, yeah, the closure traits, either the fn mute, or fn once. Awesome. So we finished up that little section. Let us now check back on our docs. Now we're going to move straight into type anonymity. Got a couple more sections today. We're going to do type anonymity, input functions, and as output parameters, and then we're going to call it. And we'll have a part 3 for the remaining sections, just because there's another nesting. So let's get right into type anonymity. So closures succinctly capture variables from enclosing scopes. Does this have any consequences? It surely does. Observe how using a closure as a function parameter requires generics, which is necessary because of how they are defined. So I'm not going to type this out. We'll just look at the docs for this one, but the f must be generic. So fn apply with our kind of angled bracket f notation that we saw previously, and the where keyword. And so then we again see our fn once, and then nothing is returned if we run this code in the browser because it's just declaring something. Okay, yeah, no output. So when a closure is defined, the compiler implicitly creates a new anonymous structure to store the captured variables inside. Meanwhile, implementing the functionality via one of the traits, fn mute, or fn once for this unknown type. This type is assigned to the variable, which is stored until calling. Since this new type is of unknown type, any usage in a function will require generics. However, an unbounded type parameter, the angled bracket t, would still be ambiguous and not be allowed. Thus, bounding by one of the traits fn mute, or fn once, which it implements, is sufficient to specify its type. VS Code time. This is a quick one. So we'll do cargo new, anonymity. I think I spelled that right. Let's open main.rs. Let's add a couple lines and then start with a function called apply using our generic type f. So it'll take input f of type uppercase F, the generic type, where f or uppercase F is the fn trait, and then it's just lowercase f. Okay. So actually we have a main already. So let me move this back. There we go. Looks a little cleaner. So add some lines there, some new lines. So let's bind a variable called x, which will have a value of 7. And so next we'll do let print equals closure. And then we just want to do println macro, curly brackets, and then just x. And then finally apply print, and then we can delete this last println macro. Save this, and then let's see what happens. So cargo run 7. Awesome. So you can see that we captured x into this anonymous type, and we implemented the fn for it, and we stored it in print. Nothing crazy, but we're able to kind of store and capture values and deal with the kind of traits for closures. This is kind of a trivial example, but I imagine in more intermediate and advanced Rust programs, these sorts of concepts become more valuable. But for the time being, this is kind of a toy example. But that's chill. Okay, that was it for an anonymity. Next, we're going to move on to our second to last page for today, called input functions. So since closures may be used as arguments, you might wonder if the same can be said about functions. And indeed they can! Exclamation point. Screaming into the void. If you declare a function that takes a closure as parameter, then any function that satisfies the trait of that bound or of that closure can be passed as a parameter. Okay, so you know the drill. Cargo new input functions, cd input functions. Open the main.rs. Add a couple lines above here so we can define some new functions. So to start, we'll define a function that takes a generic f argument bounded by fn and calls it. So we're going to do call me maybe. So f, it's bounded by fn. Interesting. And then just calls f. Next, let's define a wrapper function satisfying the fn bound. So function println I am a function. And then in our main body, let's define a closure satisfying the fn bound. So let closure equals double pipe closure println macro I'm a closure semicolon. Okay, and so now we can call our function and our closure. So we'll start with our closure, and then we'll call our function, save this, see what happens. Cargo run. I'm a closure, I'm a function. Awesome. So yeah. You can call closures and functions, or closures and functions may be used as arguments. I guess that's the take-home message of this little section. Okay, and now we move on to our final section for today as the page loads with my, at times, slow internet. But we're going to be moving on to as output parameters. So let's toggle back to the documentation. So you can see closures as input parameters are possible, so returning closures as output parameters should also be possible. However, anonymous closure types are by definition unknown, so we'll have to use the implement keyword or implement trait to return them. Excuse me. The valid traits for returning a closure are fn, fnmute, and fn_once. So beyond this, the move keyword must be used. Okay, which signals that all captures occur by value. This is required because any captures by reference would be dropped as soon as the function exited, leaving invalid references in the closure. Back to VS Code for our final rodeo of the day. So let's do cargo new, output parameters. And then let's open main.rs. Let's create some functions. Start, we'll create a function called createFN. And it uses the IMPL trait with the FN, the IMPL trait for FN, and it just returns let text equals FN to owned, and then move closure println macro. This is a curly brackets text. Okay, next let's do another function definition, create fnmute. And then IMPL trait for fnmute. Let text equal fnmute dot to own, very similar to the previous function we defined. And then similarly again, move with our pipes. This is a text. And then you guessed it, fn, create fn_once. I could copy paste, but it's fine. Practice typing, building the muscle memory in my ring fingers, because Rust likes a lot of ring finger action with the semicolons, the pipes, the curly brackets. It's different than the other languages I'm used to. Much less right hand ring finger dependent. This is it's weird, like the hand ergonomics of different programming languages, not something I ever thought I would think about. Okay. And then let's move on to our main function body. So let's bind a variable called fnplain, and then equals create fn. Next we'll do let a mutable fnmute equals create fnmute, and then let fn_once equals create fn_once. And then we're going to call those closures, or those functions, excuse me. fnplain, fnmute, fn once. Save, and then do cargo run. This is a fn, this is a fn mute, and this is a fn once. Very cool. I mean, not that cool, but it's all right. But yeah, this was a little mini dive into closures as output parameters and how you have to manage the kind of types using the IMPL trait, either the fn mute, or fn once. But yeah, this has been a whirlwind tour of closures. We've still got a little ways to go to get through the chapter 9 of Rust by Example functions chapter, but we have a couple more sections that we'll do in part 3, and that'll be coming soon. But I just want to say thanks for hanging out for part 2. All the tutorial links will be in the video description, but I encourage you to check out part 1 and keep an eye out for part 3. But thanks for hanging out with me today. Really enjoy learning with you all. Have a great day. I'm Alex. This has been Code Along with Alex, and see you next time.